Hi everyone, I'm Michael. We're going to be talking about troubleshooting slow queries with Explain Analyze specifically, and visualization tools, of which I work on one of them. That's called PG Mustard. I've been doing that for about 6 years now, and I also co-host a podcast with Nikolai Samokhvalov, who I've just spotted in the chat. So hi, Nick. We've been going nearly 3 years now, which is quite shocking to me at least. It's a weekly show and we do it topic by topic. But yeah, so I've been looking into this kind of thing for a while now. Today I am planning to cover a few basics, a very quick difference between explain and analyze, some steps I recommend for looking into slow queries, where tools can help, a bit of detail on some of the popular ones, and then hopefully the majority of the time will be looking at a prepared very simple example and then a complex or a slightly more complex example or two that we'll look for in the wild. Or, and this was optimistic, I think, of us, but if anybody happens to have brought a plan they want to look into, welcome to send a link or paste that in the chat and we'll have a look at one of those. So I'll keep an eye out for those at the end. We are not going to we don't have time to look at things like how to find slow queries in the first place. This assumes you're already at that stage. And we're not going to look at each field in detail. There are good talks online and I've written a glossary for that kind of thing. But yeah, we just don't have time today. So I'm going to assume like a basic bit of knowledge, or at least I'm going to explain the important things that we're looking into as we get there. So yeah, maybe not show of hands. I don't think anyone's got their video on. So feel free to pop in chat and put like an A, B, or C if you're like super familiar, moderately familiar, or pretty new to explain, just to give me a like vague idea of how much detail to go into on some of the simpler things. But yeah, if we have, okay, we've already got one of each, so that's cool. So yeah, I'll use that to kind of work out roughly how to pitch this. Looks like we've got four Bs, a couple of Cs, B plus like that. So okay, cool. So a lot of moderate, a couple of news, and yeah, I know for yeah, sure. There's at least a couple of people who are very familiar. So yeah, nice, really cool. Okay, so real mix. So super quickly, what is explain? What's explain? Analyze. Explain something you can put in front of your query to give you the execution plan. So what Postgres would do to execute the query. Explain analyze additionally executes the query server side and gives you a bit more information. For example, how long each operation took. So to actually understand that, let's look at an example. So we put explain before a query, which is just doing select star from table T, order by name, which is one of our columns, and we get this text back. And you read these inside out. So that little arrow is pointing to the children operations of the one above it. So the first operation that's actually happening here is a sequential scan, so a sec scan of table T. And I've highlighted the kind of most important parts at this stage, and that's it's estimating that scan will return 200,000 rows, and then after scanning that data, it's going to sort it, and the sort key is name, unsurprisingly, and it's going to return all 200,000 of those rows. So super basic example. When we add analyze to that, and this is as of version 17, this all looks slightly different in 18, which is cool. We additionally get at the bottom there, you can see execution time, planning time, and times per operation. So we get the actual time of the sequential scan, which is reported as 60.296 milliseconds, and actually returns a little bit more, so 100 more rows than the estimate. Not that important, but just interesting that it's slightly different. And in the sort, we also get a timing. That timing is 305.804 milliseconds. That's inclusive of the sequential scan, so you have to do a bit of subtraction to calculate if you want to calculate just how long the sort took. And we get information about how the sort was done. So in this case, it's spilt to disk, or it was done on disk, and it used an external merge algorithm. So you get a bit more information about how things actually happen and why they might be slow. So in terms of steps I recommend, it's really important if you want to get accurate, or if you want to get useful information back and on how to actually speed up your queries in production, you need to be running these on as realistic a data set as possible. Postgres's query planner is using these estimates of how much data is returned at each point to make several really important decisions, including which order to join relations in or tables in, which algorithms to use for those joins. So nested loop or hash join, that's can make a real difference to the speed of the query. And additionally, even things like as important as scan type. So if you run on a tiny data set, you might get sequential scans, even if you have indexes that could be used, because it's only having to read a few pages from disk, so it might as well do that sequentially. So really important to run it on not toy-sized data, and ideally as realistic a data set as possible. Perhaps clone production, or fork, some tools call them. So yes, and then second tip is to use more than just explain, analyze. So there are lots of parameters for explain. We'll look at some in a moment, but there are lots that add useful information. And then the third tip is really important, and it kind of goes with the fourth one, because a lot of people at this point jump to trying to spot issues, especially experienced folks actually. Myself included, if I'm not careful, I will start scanning a query plan for things that I'm used to seeing as issues before actually doing the calculations or looking at a tool to see which parts are the most expensive. And yeah, so first I really recommend working out where the most expensive parts are, and only then looking at details on how to speed it up. So yeah, this is the part where tools can really help, in my opinion. So they can do those calculations for you. And once queries get a little bit more complex, query plans get complex too. And doing these calculations can be time intensive and error prone. So yeah, it's a real benefit to be able to have all those done for you quickly. And increasingly, these tools are also starting to point out issues and see what you can do about it as well, which is cool. So some of the popular tools, and by the way, I'm extremely biased here. Obviously, I work on one of these, PG Mustard, but I am a fan of the others, and hoping to do them justice. If you have favorite features, or if I miss anything that you use in one of these, chuck it in chat, and I'll mention it as well. It will probably just be forgetfulness rather than not knowing. I know them quite well, which is nice. So yeah, these three, there's a lot of history behind them. In fact, Elizabeth mentioned the blog post I wrote on various tools in the invitation to this. So a bit more history on each of them is in that. But what we'll do today is use each of these to actually look into slow query plans. So we'll get to the details in a moment. And there were tons more than this. So even if none of these particularly suit you, there's probably a tool out there that will suit you. So yeah, this is a point where the text gets too small, but these are just some screenshots for now. This is the first one, explain.depeche.com. One thing I really like about this is it mostly preserves a text format that you might be familiar with. If you're already super familiar working with explain, analyze, you get that data on there on the right in the format you're expecting it. Additionally, you get timing calculations on the left and a few other little things like row estimate calculations and color coding of issues. So you can see there in red, there's the highest amount of time is highlighted in red, then some medium kind of issues in orange, and some like lower intensity issues in yellow. So yeah, this tool is free and open source. You can use it locally, or you can use the hosted version. It does those calculations and does support. So it doesn't just support text. Some people don't realize it also supports other formats like JSON. And yeah, that color coding's a real strength of it. Another really popular tool is called explain.dalabo.com, and this is called Pev2 as well on the repo, because it was originally a fork. I think it's probably mostly rewritten at this point, but of a tool called Pev, which was written by a guy called Alex Tatians. But this has been completely revived and updated and modernized. So lots of really cool features. It adds, it's much more visual than explain.depeche tool. So on the right, you can see a tree diagram of these operations with the parent at the top and each of the child operations below. And there's a few different visualizations that we'll look at. Perhaps the most useful is this one on the left, which is looking at the statistics per operation. I've got time highlighted, but you can highlight anything, including buffers. So yeah, there's lots of cool things about this tool. And crucially, it highlights some of these tips, not tips, sorry, issues in the same kind of color coding as explain.depeche.com. So you see these red thumbs down arrows. These are for bad row estimates. You've got some kind of bad timings and a few other different types of costs here in dollars. So yeah. Also free and open source. Also, you can run it locally very easily or use the hosted version. Also supports text and JSON. Very cool. Adds a few more different categories of issues than explain.depeche, but otherwise very similar, other than being very visual, of course. And then this is the tool I work on, PG Mustard. Very different again. Kind of similar, I guess, in the sense that we've got the tree view, but it's kind of mimics the text format in terms of the indentation. A few calculations shown on the tree. It also has this timing bar, which is a bit different to the others. That's just each kind of operation, kind of the per operation time ordered by slowest to quickest. So you get a quick idea of like where the time's going. And then the big difference is it adds some tips scored based on the estimate of how much time they could save. So yeah, it's different in the sense that it's also commercial, a bit more opinionated than the other tools, and it has tips for a few more issue types again, scored by time saving potential, as I mentioned. So yeah, we are going to look at a simple example to start with, and then hopefully find a slightly more complex one from the wild. We're going to create a quick table here, only 1 million rows, and we're going to have a primary key, a couple of other columns, one that's got numbers in it, random numbers, integers, sorry, 1 to 10, and another that's got random integers, 1 to 100,000, just to give us some test data. Going to stick an index on it, vacuum it, and run a simple select query. Let's see, hopefully I've already tidied this up. Oh, and we're just going to tune it very, very slightly just to encourage index scans. Set the random page cost to 1.1. That's the only modification I'm making. So let's create that table, insert that data. Hopefully you're seeing all this. Let me know in the chat if not.
Looks good.
Good. Thanks, Elizabeth. So yeah, this is just to give an idea of what the data looks like. Primary key, random integers 1 to 10, random integers 1 to 100,000. Let's create that index and vacuum it. Get some stats as well with analyze. Different analyze, very confusingly. Cool, so we're going to run a simple query, select ID from example, where the column 10 has the number 9 in it and the column 100,000 is greater than, it excludes almost all the data basically. So quite a selective query. We're going to use all of the explain parameters. So this isn't actually all of them, but if you use this, you get all of the information that you can from Postgres 17 plus. So yeah, let's actually run it. This is going to give us in text format. So this is text format explain plan. This is about as simple as it can get, right? Single operation. We're getting a lot more information than we got in that original one, and we're getting some additional. In fact, actually, because I've only run this once, we're getting a lot of planning buffers. So top tip, run the query a couple of times, especially when the data is brand new. And let's look at what that, in fact, let's go back to our browser and we're going to view it in a few of these tools just to look for any optimization opportunities. So this is a super fast query, but if you're running it many thousand times per second, it might still be your dominant query. But anyway, we're mostly just using it as an example. So in text format, you can see you might kind of automatically look for a few issues, but we can see the execution time's pretty fast. 3/10 of a millisecond. Um, the index scan itself is about 2/10 of a millisecond, a bit of planning additionally, a few statistics that look interesting, but let's view it here. So very, very simple, single node plan. Nice thing in explain.depeche.com is it's highlighting a filter issue here. So it's not highlighting the row estimate. Row estimate's pretty good because we ran analyze probably. It is highlighting the time, of course, because that's the majority of the time. But here we're seeing that only 10 rows were returned, but Postgres had to filter out 94 using the filter, the column 10 equals 9. Possibly confusing, actually, way of saying it. But because that wasn't included in our index definition, we only had the index on the column 100,000, remember. It couldn't use an index for that condition. Interesting. So there's potential for opportunity. There's a potential for optimization there. Let's look at the same plan in Dalabo. We'll get very similar information, of course. Lots of red, and crucially, 90% of rows removed by filter. Great. That's a sign we could do something about it. Same with PG Mustard. We get this 5-star tip that there's an index efficiency issue, and also that there's index-only scan potential, which makes sense. Another slight difference is you see this planning time actually is not insignificant compared to the execution of that index scan. So something else you might want to look into in terms of maybe prepared statements or something. But yeah, basically all of them pointing at this index scan having some efficiency issues, which is cool. We can quickly create if we choose to, we could say this is a problem and we want to optimize it. If we create an index on both columns, first 10 because that's the quality condition, and then 100,000 because that's the range condition, we should get a more efficient query plan. So another thing I'm going to actually go back to just quickly is the buffers. See in chat, Nick's already on the case, but yeah, the buffers here were 107 pages. So 8 kilobytes per page is only about a megabyte of data, a bit less. And we're going to also look at that in the sped up version, or with the new index. We'll see if it's any better. So yeah, we can already see that buffers hit is 13. It's almost certainly faster, yet quite a lot faster as well. But and let's run it a couple of times just to warm the cache up. I think we're good actually. Let's copy and paste it over to those tools. In fact, actually, Depeche does have an add optimization button, which is cool, which will just link the two plans. Might as well use that. Only get an orange at this point. And yeah, no filter highlighting. No filter at all, in fact. So that's cool. Let's look at Dalabo, do new plan. We do get something from, like, the cost is high, of course, but I mean, because it's saying this node is the most costly in this plan. That would be more useful when there are more nodes, of course. So we'll look at that in a moment. I don't think there's... Oh yeah, actually something else that's cool in Dalabo. They've added this grid view, which you might prefer. It's particularly good for complex query plans where there's a lot of nodes, but it means you don't have to view it in this kind of more graphical sense. But yeah, you don't get this. So I quite like this view here. So yeah, depending on your preference, you might prefer that. And then the new, in fact, actually, we have that feature as well, add optimization. Let's do, is that the first version? No, I don't think it is. Oh yeah, it is. Cool. So yeah, super fast at this point. In fact, planning time dominated. There is still that tip about index only scans. So yeah, actually, maybe what I should have done, and I've got it here. is we could have also included the ID. So that was the payload. Like we're not filtering based on it, but we are returning it. So if we added that as an include, we might get even fewer buffers. Actually, I think I tested it and we didn't. But yeah, there's a potential optimization here, not scoring very highly. So these are out of 5. So it might make a small difference, but because we're planning time dominated at this point, it's not going to make a huge difference. So yeah, that's a super simple example. Let me know in chat. Oh, got a question. Does Postgres support audit? Oh yeah, so I'm using Postgres here. I like it as a visual client. It only supports Postgres and it only runs on macOS. So other clients are available. Yeah, let me know in chat if you have any other recommendation there for dbeaver. It is good. I personally found it a little bit slow to load compared to Postgres for Mac specifically, but there are loads of other good ones. And yeah, dbeaver is really, really popular, especially amongst PostGIS folk, because it does some good visualizations of GIS data. So yeah, if anybody brought a query plan, now's a great time to paste it in the chat or let me know. But otherwise, there's this quite cool history. So when you submit plans to Depeche, there's this this feature to have plans be visible on the history page. So it means we get a kind of a cache of lots of real world slow query plans. So I'm going to look at some from earlier today. I haven't. I thought this would make it as fair a test as possible, but also kind of give us some interesting real world things and see what we get. I'm going to look for something a bit more complex than just the one node we've looked for so far. Explain example. Just looking in the chat again. JSON B fields. Yeah, so the question is, do we have an explain example of a table having JSON B fields? It wouldn't be hard to come up with one, but it's not that different in the, so you get a different filter condition, but the actual explain plan would be extremely similar. So you still get a sequential scan or an index scan, or could you get an index only scan? Yeah, so you'd still see the same information, joins, scans, and you'd still spot issues the same way. So it's yeah, feel free to clarify if you mean something else, but it doesn't look very different. Right, so we already stumbled across a much more complex example. So this one looks like a good candidate. Let's open a few more. Oh, does somebody want to pop in with a question?
Sorry, no, I just hit the wrong button.
Oh, no worries. Hey, Dave.
Hi.
Awesome. So, oh, in fact, we've got a few more complex ones. This is cool. So yeah, as you can see, if you want to look at some slow plan examples, this page is awesome. This one actually looks, this is the longest we've got, so maybe let's start with that one. So we're going to copy the source from Depeche, but we're also...
where I fade out on caring about explain is these really long plans. So I don't, if you have a second, maybe you can talk about, yeah, getting from the simple plans to the really, really complex.
Yeah, sure. Maybe let's start at a medium-sized one. What do you reckon?
Oh, no, you can start with the big ones. That's where I feel like I really struggle with like actually trying to make progress.
Yeah, right. And this is where that step 3 is really important. So getting to where the bottleneck is, or which part of this is slow, is really important, because it means you can mostly ignore the rest of the plan. So sometimes it's really important to understand the exact plan shape and all of the details, but sometimes a whole section of the plan is fast already and we can mostly ignore it. We can get to the part that's slow and work out, is there just one missing index and this whole thing will be fast all of a sudden? Or is there a bad row estimate right near the top of this plan that's causing the whole issue? So if we can narrow down to where's the bottleneck first, we can mostly ignore the rest of the plan. So that can be extremely helpful. Another tip is, once you've worked out which part is slow, you can start to simplify the query to try and reproduce the issue in a simpler query first. So between those two tips, you can start to reduce the mental overhead of kind of keep all this in mind while you're debugging and troubleshooting. So yeah, but I think in the real world, the truth is a lot of slow queries are a bit more complex. Obviously, you can get a lot of point lookups, and a lot of queries can be slow just from missing indexes, even if they're super simple. But yeah, a lot of them are more complex, as we can see opening a few of the ones that people are looking at least the ones people paste into visualization tools. I guess it might be a very biased sample set. So yeah, let's actually look at this was the really long one, right? In fact, actually, this one doesn't have buffers even. So this is long without buffers, without verbose, without settings, so without most of the parameters. So even without those, we've got a fairly complex plan here, or fairly long, I should say. It would be the same level of complexity. And one nice feature, sometimes I like to look at these in exclusive mode in Depeche, just because it only then looks at the time exclusive of children. So you get an idea of which of these nodes individually are the slowest. So that points at this sort, which is doing an external merge sort on disk using about 74 megabytes of space. So yeah, this is automatic, like very quickly, to Elizabeth's point, points us at this, and we can think, interesting. Can we avoid this sort? It looks like it might be sorting on quite a lot, so maybe we can't. If not, can we do it in memory instead? Like we might be able to speed up this query significantly just by doing that without having to worry about the whole rest of this plan, which is relatively quick in comparison. But before doing so, let's quickly look at, well, in fact, we can't do the optimization step here, sadly. That's the only downside of looking at these plans from the wild. But yeah, so if you wanted to kind of get a picture of it more visually, I know this is quite small at this point, but you can get a much more visual view in Dalabo. And we can see, well, okay, so this is where timing calculations become interesting. CTEs make things quite complex in terms of calculating timings and apportioning time between nodes, so that they add up to 100%. A little bit tricky. But yeah, so different tools do it slightly differently, but this is that same sort, I think. So 27 seconds out of 50. It's reporting that this CT is 50. Yeah, anyway, okay, so there's a bit of double counting going on here, but the sort stands out quickly, and we probably point out exactly the same. So yeah, that sort is the slowest. We do actually also have, okay, yeah. So there is a potential additional issue here. So in version 12, the default behavior around CTEs changed from being materialized always to not being, or being materialized by default if they're referenced more than once, so twice or more. But there's some subtlety here around exactly how this works, and they can still be an optimization fence when you don't want them to be. So we look out for those issues as well. And then there's that operation on disk scoring quite highly, and a bad row estimate. So in fact, if we looked closely, we probably saw that. So yeah, we see these thumbs down arrows for bad row estimates in the other tools as well, and in Depeche as well. Sorry, yes, Depeche, we get this kind of bad row estimate underestimated by 202 or 415 at different points, 897 even. So yeah, at various points there are these bad row estimates. But yeah, so you get an idea of how you can, even in a complex plan, jump straight to which parts are the slowest, and then based on the details in that area of the plan, what could we try to speed this up? So hopefully that's helpful. I'm conscious of time, Elizabeth. I think we're probably at about 30 minutes, maybe a bit longer actually. I can carry on. If people have questions, now's a great time. Equally, in fact, actually, let me just check. I don't think I had more. So yeah, examples, history. Yeah, so these slides, I've got these slides if anybody wants them afterwards. at pgmaster.com/meetup25. That is the year, not the number of meetups I've done, thankfully. And yeah, I'm basically all of the Postgres communities as MI Christofides. That's my email address if you've got anything that you want to send me privately. I'm always interested in what kind of issues performance-wise people are facing, whether or not we can help. But yeah, feel free to get in touch. Did someone have a question? Oh, what are the Slack
KJ,
Discord?
oh, you want the community Slack, KJ, or which Slack are you looking for? Michael, I wasn't able to pull up the slides with that URL. I don't know if you want to
Oh,
paste that into the chat, maybe.
yeah, of course. Doing that now. And this repository has a few links to the various communities, I think. If I could type. Here we go. So in terms of the Discord links, and in fact, I'm not sure they're all there. There is a new Discord, new as in probably the last 2 years, run by, I think, Robert Hass, amongst others, maybe, for Postgres hacking, which is really cool. I only just recently joined it myself. I don't think that's on here yet, but it's probably available if you search those words. Any questions? Oh, there's Benjamin. Do you have your hand up? Sorry.
Yeah. Yes,
Hey.
I do, Michael. Thank you. Thank you. And also thank you for Postgres FM. You and Nick, I'm a regular listener and I've learned a great deal from it. Right. So
thank you. You're most welcome. That's great to hear.
Yeah. My question, actually, I probably have more than one, but the question I think that's probably most interesting is this one. Have you looked at the explain functionality provided by other databases, other DBMSs? And if so, are there features that they support that you would like to see integrated into Postgres?
Great question. So yeah, a little bit, yes. I actually think Postgres is, if not the best, up there with the best I've seen.
Okay.
And in terms of, especially once you include those other parameters like buffers, specifically verbose, yeah, various of the others, even serialize now is super useful. I'd love to see that on by default. So yeah, I've seen a bit of my background is in tools for SQL Server and Oracle and even MySQL a little bit. So I've seen those, at least. I wasn't working on performance tools at the time, but Oracle and SQL Server do have a lot of good information. MySQL is getting there. They actually only got analyzed in, I think, version 8, so it's getting there. And the one that I saw that seems to be the most far behind at the moment is SQLite, which is, I suspect they'll add it as they support more and more complex stuff. But I was a bit surprised because I hear so many good things about SQLite, and I think it complements Postgres quite nicely in a lot of use cases. So, yeah, I haven't seen anything from other databases I'd like to see more in Postgres Explain, but there are a lot of improvements I'd like to see in Postgres Explain still. And we've got a couple of them coming in version 18 actually. So one is buffers will be on by default with explain analyze, so we'll no longer have to add that, and it means more people will see it by default, which is really important for spotting a lot of types of issues. So that's huge news. And then the other really important one is the estimated number of rows returned is a per loop average, and at the moment it's an integer rounded to the nearest integer. So it's if the estimated row, or if the rows per, not just estimated, sorry, the actual rows as well. So, so the actual rows is also a per loop average, and it means if the actual number of rows being returned per loop is between 0 and 1, so if you've got a lot of loops, which is possible, you can have thousands of loops sometimes, if it's being rounded down to 0 or around the kind of 0 to 1 to 2 kind of range, you can have quite a lot of difference between. It's not actually 0 for starters, which can be off-putting or misleading. And there's a big difference between 0.01 rows per loop and 0.49, but they both get reported as 0. So that's coming. So it's going to move from being an integer to being, well, I think it's going to be to 2 decimal places. So that makes it doesn't solve the problem, but it makes a huge difference.
Thank you.
No worries. I'm not sure that's a great answer, but yeah, there's a few cool things coming, and I'm sure there's tons more improvements that could be made.
No, that's a good answer. Thanks.
Nice. Any more questions?
Um, I have been wondering if you've seen anyone working on development for this or you've considered it, and that's just connecting the explain visualization stuff and like more explain stuff to an actual database, right? So like right now to kind of get, you're sort of, it's a little bit messy, right? Like it's a little awkward. And I guess like I do it some. It's like I don't use explain every single day. But I feel like for me, and I don't know if other people feel like this, it's just an awkward workflow, right? You have to find the query first of all, like you have to dig through your logs or find what it is you want to actually work on, and then set up a separate, kind of session to even run the explain plans, and then you're kind of off in another world, right? Like you're working through these other websites or whatever. Like I guess like I'm just curious how, if you've seen anyone think about kind of making that a little smoother of a workflow.
Yeah, well, good. Yeah, good question. I guess there's a bit of a split here, right? There's people running it for themselves on their own data often don't have this problem. It's kind of it so they can run explain analyze on either a copy of their data or sometimes even on production. But if you're trying to reproduce this issue, you need kind of test cases, or you need like sample data, or you need a script that reproduces the issue. And or like I think I don't think you're leading towards this, but for example, Crunchy Data you have the playground, right? Like, and I think you even have a tutorial, like you have various tutorials that people can very easily go through setting up a schema, setting up data, adding some indexes, doing things in a playground environment without having to run things themselves locally. So yeah, it's harder from a position of educating or helping others than it is doing it on your own, I think, generally. Is that roughly what you meant, or did I
Oh, yeah,
misunderstand?
kind of. I was just more like, to me, it just seems like the future of like the stuff that we're talking about is some kind of integration with a database, right? So that you can test new plans or read plans. Like the explain output for Postgres isn't amazing, right? And so to like, I think as a stopgap, people have built these little visualization things so that it's easier to read the plans that Postgres outputs. And it kind of seems like long term, it would be nice if there was a way to just, integrate that into your actual database so that you could read that stuff as you're working inside the database.
Okay, sure. I see what you mean. Well, I think this is a really interesting question, and I think it might not be as simple or obvious as people want it to be. So, for example, SQL Server have tuning advisor tools. A lot of, in fact, probably most of the commercial database companies have these tuning advisor tools that try and tell you what to do to improve things. And there's also auto tuning products on the market on trying to say, well, instead of knowing that I should add an index, why don't you add the indexes for me? Or why don't you tune these parameter settings for me? And they come with trade-offs, basically. Like there's it's not always like as simple as I want to optimize for minimum uh, query latency, like or read queries. You might want to do that, but not at too high a cost to write. And adding indexes has that knock-on effect. So there's often more like slightly more complex requirements than we believe because we're juggling them in our head all the time, right? We're juggling how fast do I need queries to be on average, or how much do I want to spend on my database? Like, what's my budget? How much time do I have to look into this? Or how busy is our team already? Like, you might make different trade-offs at different points, and automated tools and doing things on database side for users or is actually, it's in my opinion, more complex than people think. And I think some of these tools that are actually on the more on the basic side that present the information like Postgres is doing with Explain, it's very factual. So Postgres Explain output I've actually grown to love the text format more and more over the years. I think it's incredibly compact, it's incredibly factual. The information is there and it is not opinionated at all. It doesn't tell you what to do or that something is an issue or isn't an issue. And then to varying degrees, perhaps Depeche the least, Dalibor a bit more, and PG Mustard more. These tools get more opinionated on like assuming what you're trying to do. So with PG Mustard, we assume when you're looking at a plan, you're trying to speed it up. That's might sound like a safe assumption, but it's not what everybody's trying to do when looking into Explain Plan. So there are these like assumptions built into some of this tooling, and there are trade-offs. So in the tips we give, we quite often don't say do this. We say this is what's slow. This is why it might be slow. Here's some things to look into. Here are some options you have depending on your the trade-offs you want to make. One of these might be more appropriate than another. So yeah, I think I think and hope it's slightly more complex than that. I guess I've built tools around that. I might be wrong. It might be that we're all kind of using self-tuning LLM style agents to manage our databases in the coming years. But personally, I still think we're a bit further away from that. So yeah, I guess the short version is I'm not sure how much Postgres can do database side without getting opinionated, and it's not something it's historically seemed to want to do. It seems to want to stay factual. Here's what we calculated. Here are the costs. Here's the timings. We're not even going to try and estimate or give an approximation for per node timings. We're going to give you what we measure, which is the more accurate. This is the parent time. So it's tricky. But yeah, we in terms of I was going to quickly look for the Discord. I think Robert probably mentions it in here. So this is a initiative he's doing around community. I'll paste that in the chat now. And then Nikolai also sent through if we thought the last query plan was complex, this one's got a bit more going on. So we could look at that in a moment if we don't have any more questions. Oh, got somebody else, Dave in the chat saying he likes Postgres Explain now too, although it did take a while to get used to. So yeah, agreed.
I've been liking the JSON output. Like for me, it's a little bit easier to read since everything's labeled. I think if you're really, really used to Explain, you don't need every line labeled like that. But yeah.
I agree, Elizabeth.
I'm gonna give myself a C+ now after talking to you guys.
I like it. But yeah, so for anybody unfamiliar, you can also get Explain plans in JSON format or YAML or XML, and each field is listed and labeled slightly differently. So you actually get told this is the startup cost instead of it just being in the parentheses under cost. And you get all the information that is excluded from Explain, analyze, output as well. So text format output doesn't include values that might be zeros. So for example, it's a lot more verbose. There's a lot more data coming back via JSON, and it's therefore like more information to read. But as you say, you get explained a little bit more what each field is, and mostly I think we've used the JSON version of the naming in that glossary I mentioned. So that might be another place if you've ever got a question on what kind of a node is, or for each node type, what one of those fields is. You might recognize some of these from the JSON output, Elizabeth. So yeah, you get a field for each of these for each operation. Well, give or take. So that glossary is here. Anything else?
I guess it's time to look at that big plan.
Yeah, let's look at it in,
The
oh, here
biggest
we go.
plan that Nick could find.
This is it in Dalabo. That's small even on my screen, so I can't even imagine what it looks like for you guys. Already getting this aggregate kind of standing out maybe a little bit in terms of timing at least. Let's look at buffers. Interesting. So I'm also going to look at it in PG Mustard. So yeah. Oh, custom scan. So yeah, this is where in the slightly more complex ones, sometimes tools disagree a little bit on timings. I'm also going to give a shout out to, there's a tool, sadly not being worked on currently, but by a guy called Felix Geisendorfer, who put a lot of effort into timing. He called it quirk corrections, but actually it only accepts JSON format. So I don't think we can use it for this one. But I sometimes use that to double check timings. We've put a lot of effort into quirk corrections as well. But yeah, so there's this. Where was it? Here we go. This custom scan. So I wonder if this is hyperchunks. Yeah, cool. So this is a timescale thing. Chunk append. For some reason, that is reporting as taking a decent chunk of the time. We're getting index only scans over a bunch of partitions here, it looks like. But most of the partitions are returning 0 rows. Oh, great. Let's look at the query as well. Oh, recursive CTE, sure. Oh, I think Nikolai knows exactly what he's doing here. This is a tricky one. But yeah, basically it's the same process as always, right? Like try and work out where the time's going. If it was dominated by one operation, we'd be a bit more optimistic of a big speed up without having to have a rethink of the query or the approach. In terms of data read, I didn't actually look at the total buffers, but okay, so some of buffers here. This is a bit of a controversial or a very opinionated metric. It's not scientific in any way. It doesn't make sense. It doesn't make a lot of sense to sum all of the buffer statistics. They mean very different things, but we use it as kind of like a proxy for roughly how much work is being done here. So not good science, but practically useful, I think. And it's doing about 9 gigabytes of stuff. So like reads, probably a lot of reads, but just gives you an idea of roughly how much work's being done. So a second, I'd hope we could get it a bit faster than that. Let's look up there. Yeah, so this aggregate, I think that's what one of the other tools was pointing at. It says 424 milliseconds out of the second. PG Mustard is saying a bit lower. So I'm a bit skeptical of that. Good that you're getting index only scans on these. It's reporting 0 rows returned per partition. So I'm wondering if we could exclude like if there's a partition exclusion issue here. Or it could be a rounding issue, as we discussed earlier. I don't think these are being done in loops, so no, maybe not that. That would be where I'd start. Looks like all of the data is actually coming from only a few partitions. So yeah, that would be a starting point, is can we exclude more partitions earlier? But yeah, interesting. Oh, and yeah, what's happening here is you might notice this perhaps not looking quite as daunting in PG Mustard, but we are hiding a lot. So again, opinionated, this is another thing that's perhaps controversial. By default, we collapse those. Like anything super fast already, any subtrees that are happening nearly instantly or taking very low percentage of the time just get collapsed by default. They can be expanded very easily, but it means we can focus. Like it goes to that process. Focus on where the times or where the work's being done, which parts of this are the bottleneck, and then kind of expand out your search as you try and solve the problem. But yeah, let's see what tips actually we gave here. Rows discarded here, yeah. So because of that limit 100 at the bottom of the query, we're having to do a lot of work and then limit. So we're not actually potentially like, yeah, we're perhaps doing exactly the exact same amount of work as if we didn't have that limit 100. So there's also possibly an argument for doing all the work, and then if you want to paginate client side, it wouldn't actually take any more time that first run. So yeah, it's a tricky problem, I think, this one. But yeah, hopefully that's well. Let me know what you think, Nick. I can see a thumbs up. Cool. I think we're probably nearly at time, but anything else, Elizabeth? Anything I've forgotten to say?
I don't think so. This was super helpful for me, as a C plus explain person. I super appreciate how much you know about this topic. And yeah, I guess I hadn't considered, like, I liked your sort of approach of doing a couple different, a couple different of these tools. To use PG Mustard, you get like something through you guys first, and then you can see the explain plans, or how does that work?
So yeah, all of these. So these other tools are free and open source. You can just go to the website and use them straight away.
Yeah.
Because we give people like a free trial of like a few credits each
Okay.
time you plan. You need to sign up basically. It's like a free trial
Okay.
thing. But yeah, then it works exactly the same. Just paste plans in from wherever. Ideally, yeah. So we don't. In fact, that's probably a good clarification. By default, if you use the other online tools, they publish the plans by default, so you can share them. But so if you're working with sensitive data, and explain plans can contain sensitive data, you probably want to use those tools locally instead. For that reason, we actually don't store plans server side by default. So we only store plans in local browser storage. So if you do want to share them, you need to publish them. But it means, yeah, it's just slightly less chance of sensitive data being leaked at any point.
Yeah, I wondered that too when you were going through
Yeah.
the Depez stuff. But yeah, well,
Yeah,
thanks. Oh, go ahead.
sorry. Well, fingers crossed people only use this for plans that can be shared
Right. Yeah.
publicly, yeah.
Well, yeah, thank you so much for being here, Michael. And thanks for everybody who joined us. And if you're new, if you missed my little update, next month we're talking about just developer mistakes. Andy Atkinson will be here. He does a lot with Ruby on Rails performance and Postgres. So it'll be kind of a deep dive into sort of application performance with Postgres. So I hope you can join us next month. I'll post this recording a little bit later today. So thanks so much, Michael. Appreciate everybody. See you guys. Have a great day.